We were on. Good morning, ladies and gentlemen. It's good to see so many people interested in IPv6 joining us today. And so today with us, we have Adrian, to my left. To my right, we have Alain Fiocco. And on the far right, we have Chown coming to speak to us about IPv6 and various experiences. I think, shall we start with well, we can start, I guess, with Tim, with the IPv6 matrix. Give us a little background on how well IPv6 is doing in the UK so far, and then afterwards we'll have Alain, and then Adrian, and then we'll start a discussion with everyone, and among us as well, probably. It's great to be able to touch on this. This is being streamed by WebEx, and we'll also have a remote moderator who's sitting in the far corner and who will be shouting out if there are any questions from remote participants. And I know there are several remote participants at the moment. So I see, okay, so the sound is working as well. Tim, over to you.
Hi, welcome everybody. So I'm here just to talk a little bit about measuring IPv6 deployment, and more specifically, a project we've been doing with ISOC UK England chapter at the University of Southampton to enhance an existing measurement tool, make it far more interactive, and something that hopefully a lot of people will find useful, but more of that in a moment. So there are obviously a lot of people out there measuring IPv6 deployment at the moment. There's a lot of sites that you can go to and find lots of useful information. On the slide there are a couple of links to a couple of sites where people have catalogued various measurement tools and software. So you can go there and get a good overview of the types of things available. But the main problem with a lot of these systems is that although the numbers are good and there's more and more numbers than you can probably handle, they're generally presented in a very matter-of-fact style, and they're not very interactive. So if you want to dive into the data and get a better understanding of what's going on, it's not necessarily that easy to do so. Also, I'd also say that in many cases, although there's lots of web pages containing visualizations and data, not many of the people that collect the data make the data available openly in a format where you can process it and perhaps merge it with your data to produce interesting new insights. So that's something that we're going to tackle. So what type of things can you measure? There's obviously an awful lot of things you can do. You can look at the number of prefixes that have been allocated to ISPs or provider-independent prefixes more recently that have begun to be issued to sites more recently. There's a lot of things that you can look at. What we'll focus on with the IPv6 matrix is IPv6-enabled websites, DNS servers, mail exchanges, those types of services. And that's what that tool focuses on. If you want to see a good talk about the whole deployment story of IPv6 over the last 10 to 12 years, there's a really good talk by Jeff Houston on the link that we put there. So have a look at that. It's well worth a gander. So some examples of some stats and charts that you can see out there. There's one by Google. If you just Google for Google IPv6 stats, you'll find this stuff. This is showing you the percentage of users that come into Google over IPv6. Pretty much all of Google's services are IPv6 enabled. So if you're on an IPv6 device, then you will talk to Google services over V6. So we're currently at 3.5 to 4% of the traffic going to Google is V6. That doesn't sound like a lot, but if you consider back just 2 years ago, that was 0.5%. The curve is going in the right direction, and hopefully if it continues on that path, those numbers can get much more impressive quite quickly. Next slide. Google also aggregate the stats per country. So the way the beamer's working here, you can't even see the UK. But what this is indicating is the darker the shade of green, the more IPv6 users there are as far as Google's concerned in the country. So they're seeing users coming from these countries to their services. So you can see Belgium there is very dark. That's because a lot of their ISPs have deployed IPv6 now. You've got Germany a little lighter, France a little lighter than that, and then the UK, you can barely see it. So that's an indication of the lack of V6 deployments in the UK. Next slide. One of the other things you can look at, I mentioned just now, is the number of V6 routes on what we might loosely call the internet background. Obviously, it depends where you look as to what you see. But there you can see we're up to about 18,000 routes on the V6 backbone. That contrasts to maybe 500,000 or so for V4. Now you might think from that there isn't much V6 deployment, but in practice, because the V6 prefixes have been allocated out to ISPs in a more hierarchical fashion from the start, most ISPs now have a prefix, and the lower number of prefixes is because of that initial hierarchical application. And probably some of the growth recently is perhaps due to the PI prefixes coming out and some traffic engineering practices that have been inherited from before. Then the last one here is, I guess you might be seeing this from our Cisco friend in a moment, but this is just a site showing a 6lab.cisco.com. You can go there and look at Cisco's measurements of V6 traffic as well. So onwards. So I'll just talk for the next 3 or 4 slides about the V6 matrix. So this is an existing tool that ISOC England started up a few years ago at Niall University. And they developed this in a way where it was essentially a crawler tool and a visualization tool. So what the crawler did, it would take the Alexa top 1 million websites, determine which of those had V6 DNS entries for websites or mail exchanger or DNS servers, and then test connectivity to them and measure the number of enabled sites. And then the visualization tool would show that in a fairly dry way. And unfortunately, of course, with the Arab Spring, priorities changed and that sort of died down a little. And so last year, ISOC England came to us and said, we've got this crawler, we think it's a good tool, the visualizations aren't very good, how can you help us with that? So next slide. As it happens, at our university in Southampton, we have this thing called a group design project in the 4th year, and that allows students, groups of 3, 4, or 5 students, to work with an industrial customer for their first semester developing something. So what they did here was work with Olivier and Christian from ISOC England to both harden up the crawler a little bit, but mainly focusing on the visualization side of presenting the results, and to create something interactive so that more general users could play with it and get a feel for what's going on. The data would hopefully be presented in a way that more general users could understand, people visiting the site. And also, we decided, since we're a big supporter of open data at our university, in fact, Nigel Shadbolt and others have been very prominent in that. There's the Open Data Institute here in London, which Nigel's heading up. He was behind Data.gov UK as well. So our idea here is to anything that we produce as data from the crawler, we will also export and make available to anyone. So if you've got your own data sources, you can combine with ours, and hopefully by doing that, we'll encourage other people taking measurements to put their data out there as well, rather than just producing graphs. So this is all available on IPv6matrix.org. We're hoping to do a live demo. I'm not quite sure how we're going to do that with the way the beamer's working, unless Olivier can just hold his laptop up running it or something. If you go to the next slide while he's fiddling, then okay, we're going to do some wizardry with WebEx that may mean that people here and the remote people can see the demo. Just hang on a moment. So the site is www.ipv6matrix.org. It's available, of course, over V4 or V6. Passing privileges. So, do you want to talk people through it? And okay, okay. We have some screenshots in case this doesn't work. So what you see there is the tool students have produced. They've used appropriate Java libraries, I can't remember the exact name of it, to allow production of a 3D globe that you can this is going to look good on the video as I kneel down with the laptop. So you can, I'm also used to a Mac, so this is a bit weird. So you can spin the globe around and see the hot spots, if you like, of V6 deployments, and the sampling points scroll from left to right just to show you the history of what's happening. So interestingly, you can see Tunisia there is actually quite bright. The reason for that is that means there's a very high proportion of the servers there hosted there are available over V6, but it's a very small sample size in Tunisia. There's a similar thing over here with, I think that's Bhutan, which is there in Bhutan in bright white, which they've got less than 50. But the interesting thing is at the top of the domain chart, that shows up as .bt as being highly V6 enabled. Yeah. Yeah, so the geolocation information isn't necessarily all perfect, but if I can just... Yes, yes. But you can also, as I'm about to try and show here, you can drill down. It's just chugging a little bit here through the presentation software. So you can then get to the fixed view there, and then you can drill down and see all the specific numbers. You can sort in different ways. So if you want to sort by V6 host penetration, you can say Bhutan there is 75%, but only from 57 hosts surveyed from the Alexa top 1 million. And Tunisia is a very similar thing. But of the bigger countries, you come down, the United States will be .us, but France will be the .fr is there, and I'm scrolling down and down and down. Unfortunately, I'm not finding UK very quickly here, so still going down. There we go. So that's 4.9% of the 173,000 services that were sampled by the crawler have V6 advertised and connectable to. And I can here choose to zoom in on the UK, and then I'm focusing here stats on the UK. So you can see how that percentage has changed over time through the crawler's history. The other type of thing you can do, but I won't go into it here because we're a little pressed for time. There's controls here where you can, if you want to just twiddle what domains you're searching for and handling, you can select different generic top-level domains or country domains and view those as well. And you can view the different service types that it's looking at, so web, mail exchanges, name servers, and TP servers. So that's it, basically. And we hope the idea is by having this sort of interactive tool, that makes it a little bit more interesting to scoot around the visualization and to understand what's going on. So that's what we've been working on from the university with Olivier over the last 6 months or so. And we're just, now the students have finished their exams, we're bashing them on the head to just complete the handover. So if we go back now to the rest of the presentation, I think there's only just a closing slide to go back to. But we would certainly encourage anyone to just try using that and send us some feedback. You can email feedback@ipv6matrix.org, and that will get to myself and Olivier. We'll be very happy to take any comments you have. So yeah, we're back in the room, so to speak. So if we just advance 3 or 4 slides, there's, I think, 3 screenshot slides which we can just step through now since we've seen the demo. And then the final slide, I think. Oh, no. Okay, so this is actually an important point here. I've forgotten that. So as I said, one of the things we allow, and it's in the, if you go back a slide, at the bottom left, you can't quite see it from that screenshot, but in the bottom left, there's the option there to export data. So whatever visualization you've honed in on, it could be the global thing, or it could be a specific country or a specific aspect of certain countries. You can then hit a button to export that data in a variety of formats, including JSON, which is the trendy thing people manipulate today. So the next slide shows an example of some JSON data for whatever it was that we were looking at the time. So you can take that data, throw it at whatever tools you want to produce whatever results you want to. And then I think the final slide is the next one. So yeah, this tool is now available. It's been a really interesting project to work with ISOC England to develop that. I'm hoping to do some kind of follow-up next year. We'll see how that goes. Make it global. Yeah, so perhaps deploying other observation points. So it's crawling the data from our university at the moment, but it would be good if we can just package this up as a thing you can put on a VM anywhere and crawl from that wherever you want to, and maybe merge those results. It also shows, from the point of view of our university, it shows If you've got an idea for something you'd be interested in, some students prototyping are very amenable to that. We run 30 or 40 of these projects each year. And we believe it will help promote the use of open data for analyzing deployment of new technologies, in particular V6, and encourage other measurement people to do likewise. And again, if you've got any feedback at IPv6 Matrix. Okay, thank you.
Thank you very much, Tim. Are there any questions or comments from anyone, including the panel, including the remote participation, or? Okay, then we can go to the next presentation. That's Alain Fiocco.
Thank you. Stand up in front of the audience. And turn on back on you. Yeah. So move on. I mean, this is me. So basically, what we've been doing at CISCO right from the beginning, when we started this IPv6 project, which is kind of company-wide activity, one of the first problems we had is that nobody really knew how much V6 was enabled, how much was deployed, and how it was progressing. And that was causing some troubles in terms of just defining the business case. Like, why would you enable a particular product to support IPv6 if you don't know how it is used and where it is useful? So we started this project of measuring IPv6 adoption globally on the internet, and we are essentially measuring three metrics, or actually four, but the first one is not that interesting. Three metrics. The first one is the state of the transit system. How much of the core of the internet is ready for IPv6, right? So basically we're looking at the transit autonomous systems, not the peripheral ones, just the transit ones, and I'll explain why in a second. We're looking at the content, how much content is available, and we have a very different way of gathering data in terms of the content. I'll explain that in a second. And then we are just displaying user statistics that Google is collecting country by country, but we are displaying it in a slightly different way. We're also collecting statistics from other sources, which we are not displaying yet, but we will in the near future. So if I'm looking at the core of the internet, one thing that we've done is, and these are snapshots actually of the 6lab.cisco.com/stats website. Instead of doing a live demo, I decided to take snapshots. It's a lot safer to do the presentation, but you can find the exact same thing if you go to the website. And by the way, there is a mobile version of the website as well if you prefer to go with a tablet or a telephone. But basically, what we're doing here is that we are showing all the transit ASs on the internet. There are 10,800 of them, right? 819, I think, as of this morning, as of yesterday, in fact, because we update that at 3 p.m. every day. Among those 10,000 transit ASs, 1,850 are providing transit service for IPv6, and 3,890 do have IPv6 enabled, but are not providing transit service yet. And the reason why we know that is because we don't find their AS number in the AS pass of anybody, right? Now, instead of just tracking the numbers, because not every ASs are born equal, right? Some of them are very important for the internet, and others are not that important, right? Typically, I mean, a level 3, for example, is at the very core of the internet, so they don't support V6 that will provide, you're going to have a lot of connectivity issues. A university, for example, that may be providing transit service for schools may not be that important. I mean, it will impact those schools, but it won't impact anybody else. So we are classifying those ASs based on how important they are in the transit system of the internet, based on the number of times that their AS numbers is seen in the transit pass of other downstream ASs. And so that's what I'm representing on those charts, is the position. Every dot on these circles represent one AS. The position of the dot depends on how important that AS is for the internet. As you can see, that what we see here, in fact, which is very important, is that the core of the internet, right, the top 5%, the top 300 transit ASs, or the top 500, are largely IPv6 enabled. As you move to the periphery, there is still some work to do, right? As one would expect, but I think it's good information to have that the top 300 transit ASs in the world, in terms of their importance, not in terms of traffic that they carry, but in terms of the importance for the transit system, are actually enabled with IPv6 and provide transit service to downstream ASs as well, right? So it's 85% of the top 300. And by the way, if you're looking at most of the transit ASs in the UK, at least the most important one, they are in those top 300, right? So that's the. Now I have this data country by country as well. So this is global, but you can drill down country by country. Next slide, please. Yeah, I forgot to mention that the annual growth is about 30%. So this is pretty good. This is the UK number. So if I'm taking the exact same approach, right? So of course this is too small, so you can see it on the slide, but I have the exact same thing. If you click, by the way, on the small circle represents the top 5% ASs. If you click on it, it will zoom in and will provide you the data. These are the number of ASs that are enabled. As you can see, the V6 ASs, transit ASs, are actually growing a little faster than V4 ASs, but not by a huge number, right? If you weight all of that, you end up with a transit system in the UK that is enabled for IPv6 at 71%, and about 84% of the transit AS is enabled for IPv6, but doesn't provide transit service for it. Probably because they don't have downstream customers. You know, it's not that they don't have enabled the feature, it's that they don't have any downstream customers connected to it. Now, how do the UK compare with the rest of Europe, for example? I'm a big fan of country competition here. This is World Cup time, so if you can click on the slide, you will see a few other countries showing up. What's this next slide? It's the same slide, but it's animated actually. Yeah, here we go. So you can see Norway. The Nordic countries are actually a lot darker than the UK, so they end up having, you know, over 80%, sometimes close to 90% of their transit systems IPv6 enabled and providing downstream service. Germany is, you know, in the same category. France is actually just about the same as the UK, right? From a transit system standpoint, right? And you can go on the sixth slide. You can go to any country and have a look at it. Next slide. Now it's fine to have the network, but what are you using this network for? Well, so we're measuring content, and the way we are measuring content is actually slightly different from what Tim showed before. We're not looking at the number of websites enabled, because to a large extent, it isn't useful, right? Most of the traffic and most of the users go to a very small number of websites in reality. The most important websites represent the vast majority of the traffic. If you go to the top 10, they probably represent 80% of the traffic or something like that. So basically what we did is we're looking at the top 500 websites for 130 countries. We crawl the net and test those 500 websites, and we take that information from Alexa, which means that we're not looking at the top 500 from we're looking at the top 500 from an end user standpoint, right? This is what Alexa is reporting. And you look at the UK, there are 34 sites among those top 500 that have V6 enabled, and you can download the page over V6, and that page is actually comparable to the same page over V4. So we do even the comparison of the content. Among those 34, unfortunately, in the UK, there is only one site that is actually from a UK-based company, right? One among those 34. The others are what? Facebook, Yahoo, Google, Wikipedia, you name it, right? And a bunch of others. We have 34 websites on those 500. Now, the other thing that I'm doing, which I think is quite interesting, and it's imperfect, but it's actually an estimation, I'm actually ranking those websites. Alexa is actually ranking them for me. They give me an ordered list of those top 500 websites for UK basic user. And the way, based on the number of clicks and the number of unique visitors, so it's not really content-based, but it's more like click or activity-based, if you wish. Alexa is giving me the number of clicks and the number of unique visitors that they see on every one of those 500 websites, times 130 countries. And based on that, I can calculate, you know, I can rank them. I know who's first and who's, you know, second, third, and so on, all the way to 500. But I also know how much content or how much click, how much activity they represent compared to one another, right? And so if you look at, we're testing those 500 websites, let's say for the UK, we find out that number 1, number 2, number 6, number 8, number 10, number 15, and number 300, for example, are V6 enabled. We know what is the percentage of content that they represent depending on the rank that they have. You sum that up and you end up with 45%. So it's not 45% of the bits, but it's 45% of the activities. And for an ISP, this is quite interesting to know because you know that if you enable your end users on IPv6, you know that about 45% of what they do, not what they download, but what they do, the clicks, will be accessible over IPv6, right? So from a capacity planning standpoint, this is a pretty good way of looking at it. By the way, we double-checked that estimation with real numbers from a couple of universities, one in South Africa and one in France, and we found out that plus or minus 5%, actually the estimation is accurate, right? It represents traffic, in fact. Maybe by luck, but rather than by design, but it's actually quite an accurate way of looking at it. We're also looking at sites that are testing, who have, for example, an IPv6 URL, right, the IPv6 domain specifically, and so we're tracking those as well because it's usually an indication of some activity, you know, people going, that's what I'm tracking in the development category. So in the UK, there are 5 sites among those top 500 that do have an IPv6 specific domain, right? So that means that they're doing something, right? And eventually, in a not too distant future, they're going to turn that into a production website. Now, how does the UK compare with the rest of Europe? You can go to the next slide. Sorry, one more. So Norway, for example, has 68 sites. Those that represent 48%. Czech Republic, 74 sites, are representing 60%, and so on and so forth. So I'll let you read that, right? So there is not a huge difference in terms of percentages of content, but there are more websites certainly in other countries in Europe. The reason why the percentages are not that different is because the big ones, the Google, the Facebook, are available over IPv6 everywhere, right? Now, there is a second piece of information that is very interesting. If you look at that map, you're looking at Greece is very green. The reason why Greece is very good, by the way, there are many other examples. I'm just picking up on Greece here because it's on the map, but it's true in other parts of the world. It's not because they have enabled a lot of websites in Greece for IPv6, it's because Cloudflare is providing. Everybody knows where Greece is. I don't need to point to it. So Cloudflare, back in April of this year, has enabled IPv6 for all of their users by default. So if you have a site that is cached, right, and accelerated by Cloudflare, as of a sudden it becomes reachable over IPv6 without you doing anything. And that has made certain countries become very green as of a sudden because a lot of their content is actually hosted by Cloudflare. Actually, the same is true by Kennard and a few others, but Cloudflare had a big impact in April. And that's the reason why Tanzania, for example, is very green on this map, or Greece is very green, or Tunisia. We were talking about Tunisia earlier on. Not necessarily because they've enabled a lot of websites locally, it's because they're caching or hosting a lot of their content in other people's clouds or data centers. Right? So the big message here is that for ISPs in particular, if you were to enable your users on IPv6, there is a lot of content available out there. However, there isn't a lot of local content, right? So we need to get our act together here locally. By the way, if you're looking at overall, I would say about 60% of the content that is consumed by users anywhere in Europe comes from global companies, and about 40% comes from local companies, right? Newspapers, media, banks, and very few of those have actually enabled V6 in reality. Right? Now, you would say, okay, why would I enable V6 on my website anyway? There aren't very many users on V6, right? It's a bit of a chicken and eggs. True. So there are certain countries where, if you go to the next slide, we're also tracking users. Because it's important to understand that if you're operating in a country, if you're a bank or a newspaper or a media company or an e-commerce website, and you're operating in a country where a lot of users are on IPv6, you have a much better business case or incentive to enable V6 for your end users than if you're operating in a country where you have very, very few users. So if you go to the next slide. So Google has been tracking those users. I mean, we've seen a team slide already. By the way, as of yesterday, 4.something% of the users globally. I mean, it's good to see global numbers, but it doesn't mean a lot, right? Because most of the users that come to your websites, you know, if they go to bt.com or if they go to, I don't know, Royal Bank of Scotland, they're likely to be locals, right? It's very rare that a French guy is having an account with Royal Bank of Scotland, for example, right? So click to the next slide. So I think it's important that, so if we project, you know, back in the day, we were thinking that that's exponential growth. If you project using an exponential curve, you end up with 6% at the end of this year globally. As a matter of fact, this is more than exponential. This is more like polynomial. So if you go to the click again, so we're more likely going to end in the range of 8% by the end of this year globally, right? But the thing that is more important is, by the way, this was taken in April, in February. Since February, we are tracking on the light blue, not on the dark blue. So it's actually yeah. So go to the next slide. Now, if we're projecting the same exact same curve, right? So exponential at the bottom, polynomial second order at the top, you end up with 35% minimum or 60% maximum by end of 2017. Now, this is if we continue to do what we've been doing, right? Hopefully, things will get better. So it's like running a marathon. We've just passed the 7th mile, right? So if people run the marathon, they know that once you pass the 7th mile, if you continue to hydrate and eat, you should be okay until the end. Next one. It's just a milestone. I mean, it's just, we need to consider the race, right? Keep going. Now, what is even more interesting is that if you start digging into the details, right? It's okay to know that 4% globally, but what does that really mean? Well, worldipv6launch.org is actually measuring ISP by ISP. So if you're an ISP and you give them the AS numbers that you have, they can go to most of the content platforms, Google, Facebook, Yahoo, and collect statistics and display how many of your users are going to those platforms over IPv6. And as you can see, what is really interesting is that the service providers that have decided to do it, and have decided to do it by default, that means without the users asking for it, right? The user gets the service. Verizon Wireless is about 50% of their users are on IPv6 today. Comcast, 26%. Free Telecom in France, 37%. Deutsche Telekom in Germany, 20%. Right. So if you're operating in a country like in the UK, in the US, where you have, you know, Verizon Wireless is by far the biggest mobile operator in the UK, in the US. Sorry. And if you know that this mobile operator has 50% of their users on IPv6, you better put your content on the 6 because that's otherwise you're going to underserve your customers or disenfranchise some of them. So as you can see, I mean, those numbers are pretty impressive if you start digging into the details ISP by ISP. The thing that is interesting is that, so you look at those top 4% and you would say, okay, so the places where they're running out of IPv4 addresses in China and India and Asia. Well, the reality is most of the big deployers of IPv6 are actually in the US and in Europe. They're not in Asia Pac, right? So the driver seems to be innovation more than demographics, in fact. Right? People want to do it because they want to differentiate. They want to be ahead of the curve. They want to deploy new shiny devices and kind of things and stuff like that. Not so much because they connect more end users. That may change over time, but that's the reality here. Next slide. As I was saying, you know, if you're looking at the growth curves of those customers, you know, examples of ISPs in the US, you know, AT&T, Comcast, and Verizon Wireless. So AT&T is a DSL and fiber. Comcast is cable. Verizon Wireless is actually mobile. You can see the growth curves, how things are progressing. You can see that in the wireless world, they went from 5% to 50% over 2 years. Right? Comcast went from virtually 0 to 20% in less than a year. So it's actually, as long as you're doing it by default, the growth is actually pretty impressive. You don't want to ask end users to turn on the 6 because they don't know what it is. Next. Projection again, so same concept. Right? You take Eric Winker is actually one of my colleagues who's actually operating this website where you can decide how you want to model the growth, what kind of curve you want to use, and you basically take the real number from Google and projecting. As you can see in the US by end of 2016, we should be at close to 18%. If those ISPs continue to do what they've been doing. Yep, next. Okay, so what have we done at Cisco? Well, I was lucky enough that a couple of us at Cisco went to John Chambers and say, you know, it's one thing to drive IPv6 grassroots and get the engineers to do the features, but it's the type of technology that is very, very difficult to justify from, you know, every time you want to implement V6 on a particular product, you have to build a business case. You're not going to be able to do it. Or you're going to do it in a very piecemeal approach, and we didn't want that. So we went to John, and John was, you know, really understood what the issue was, and he put those two statements, which have helped us a lot, both internally and externally, to actually kind of wake up people on V6. That was back in June of 2010. And let me read this, right? So if we don't overcome the challenge of IPv4, and he was going on and saying other things, we will slow down the growth of the internet and lose momentum as an industry. Right? This is the kind of how serious it was from his perspective. IPv6 is important to all of us, to everyone around the world. It is crucial to our ability to tie together everyone and every devices. And the Cisco commitment is, at Cisco, we are committed architecturally to IPv6 across the board, all of our devices, all of our applications, all of our services. The result of that is that we did put together what we call a high impact project at Cisco, which is something we drive across the board, which I'm responsible for, and helped us a lot to actually execute and turn on V6 on a lot of products and software. Next, please. So you can read that, but the point is we're actually enabling V6 everywhere. The most important point probably on this is not that V6 is enabling on all those things, is that we've had to change the engineering process. We had to force engineers to do V6 by the process, not because they wanted or wake up one morning and decide that was the right thing to do or the coolest thing to do. But we did change the engineering process by putting mandates and gates and stuff like that. Okay. So the other thing that I've been working on with IT is how, you know, we at Cisco decided that we couldn't drive V6 and try to lead the market without doing it ourselves, right? So we decided to do V6 internally. And I'm very happy to report that the vast majority of our web applications on Cisco.com today, and when I'm saying vast majority, it's over 95% are V6 enabled today. Which, by the way, so about 5% of the users coming to Cisco.com globally come over IPv6 today, right? 5% of the connections over IPv6, if you take 5% of the business that we book on Cisco.com, it's $2 billion. So this is the kind of business that we put at stake, or business that the risk that we were ready to take in enabling V6 on the Cisco website, right? So we were ready to do that. So we've enabled now V6 on 100% of the core wide area network, all the DMZ, the internet point of presence, all the data centers. Most of the DNS is enabled, 100% of the DHCP servers. And we have 68,000 employees at Cisco. 84% of the user VLANs are actually V6 enabled, 38% of the voice VLANs, and 91% of the labs. And this keeps growing because we did put that into the refresh cycle. It's not something that we've done as having a separated budget. We just did put V6 into the refresh cycle and just force it through the system. Next. Yeah, the one thing that I want to say is that we're running this meeting on V6, so if any of the participants, I see that Steve is actually online, so if Steve at Cisco has IPv6 from wherever he is right now, he's actually on WebEx over V6, because WebEx is actually available over V6 for somebody that has V6 connectivity. Yep, next. That's it. So feel free to go to the websites that I displayed. You can actually track over time progress or lack of in certain areas of IPv6 deployments. Thank you. Any question? Yeah.
Yeah. Nigel Titley, RIPE NCC. Right. I have a question. Does Cisco, in retrospect, regret making IPv6 an optional chargeable extra at the start of deployment of V6, and hence probably at least initially, crippling IPv6 deployment?
Well, so this is something we stopped doing 5 years ago.
5 years is not a long time.
5 years is a long time if you look at IPv6 deployments, because 5 years ago there were no IPv6 deployments anywhere. So
Partly because Cisco were charging extra for it.
Policy-wise, we're not charging extra for V6 anywhere. We have a policy of feature parity, which means that any given package that contains a certain set of features for V4 will contain the exact same features for IPv6. The only thing that we may charge extra for are transition technology. So, for example, if you want to use a NAT64 technology, or if you want to use a session load balancers to convert from 4 to 6, that is extra. There is an extra charge for that. It's a feature, right? It's a package license. But for anything else, it's actually on a given product, you have the exact same routing protocol running before V6. You have the exact same, I don't know, any of the features that you have for V4. We actually, put V6 in the exact same licenses. At the very beginning, actually, it's not that we were charging different extra, is that V6 was part of a high-level package. So we had, for example, the basic package was not containing V6, and you had to have the enterprise package to contain V6 features. But we stopped that a long time ago, right? 5 years-ish.
Thank you.
Pleasure. And by the way, do I think that this has hindered the deployment? Frankly, no, I don't think so. I think there are much bigger issues that have hindered the deployment of IPv6, and I don't think that was a big factor. To be very honest with you, as soon as we got customer feedback that there was something that they really didn't want to see because they were planning to deploy in massive scale, we'd stop doing it. We actually reverted back to a feature parity policy.
Working for ISPs for much of my life, I would say that it did definitely discourage IPv6 deployment. Because in certain ISPs, we didn't deploy V6 because it would have cost us more for Cisco licensing.
So it's actually, so let me make I'm actually very surprised with that, because the service provider platforms did not have this extra charge. It was actually embedded into the exact same licenses.
I'm talking 10 years ago. I'm talking 10 years ago.
Oh, 10 years ago.
Okay, but 10 years ago is when we should have been deploying V6.
Yeah. All right. Knock on here.
Thank you. Eleanor Bradley from Nominet. I suppose to ask the obvious question then, and maybe we're going to come to this as well about internet service provider behaviours as well, but why is it so difficult in the UK? Why are the numbers so poor in comparison to other countries? Excellent. Well, I'd like to provide the introduction now for Adrian.
but to be fair, I don't think this is harder in the UK than anywhere else. I mean, it's hard. It's hard to justify. You need to have a business driver, and it may not be obvious. I don't think it's more complex or more difficult or more. There is no reason why it would be in the UK than anywhere else. So I'm curious to understand the reasons from your perspective, but I don't think there are UK specifics. That's my point.
I have a question before we go to Adrian. You mentioned the natural replenishment of your equipment and so on. So a product life cycle, basically. Do you see this happening with your customers as well, then, that they're going, and what is the product life cycle of a standard Cisco customer?
So product life cycle and refresh. So indeed, in Cisco IT, we actually did the deployment of IPv6 with $0 incremental budget. Okay, it wasn't something that we budgeted for. It was done as part of the normal refresh cycle. It was just a matter of defining the policy, defining the processes, defining the new configs. And we have a contract with IT that every 3 years they actually refresh. Actually, it's every 2 years for software configs and every 3 years from a hardware standpoint. So most of the products were already supporting V6 from a hardware standpoint. It was just a matter of upgrading features or upgrading software. So that is done on a regular basis. Now, does that happen with customers? Absolutely. The same kind of things happen with customers. We have a number of customers that have already put V6 as a mandatory procurement. When they procure products, they have to support V6, and they turn on V6 once they decide to do it. That's the only way to do it. It's just put it through the refresh cycle and the process and turn on V6. Service providers are a bit different because they need to have a specific V6 project. In particular, they do run out of IPv4 so I would say that's probably a different life cycle or different transition mechanisms or business case. But for enterprise, yeah, well, so life cycle depends on the products, but I would say, so first of all, I would say any product that have shipped less than 5 years ago do have support in hardware. So you may have to upgrade your software if you want to have particular features that may have shipped only recently or relatively recently. But from a hardware standpoint, you should be okay. Some customers have a refresh policy every 7 years and others every 3 years and anything in between. Right? I don't think that it's less than 3 years, but it's some people refresh quite often and others don't. Depends on their application needs, bandwidth consumption, and so on and so forth.
All right, thank you very much, Alain. So next we have Adrian Kennard.
Right. I might as well stand up, but I'm blind now. I've been asked to try and explain some of the challenges that ISPs are facing in deploying IP6. And we're an ISP, and we've been giving our customers IP6 for 12 years. Not as long as people like Janet, but we have been doing it quite a while. And it was incredibly easy. But during those 12 years, there have been various challenges we have faced, and pretty much all the challenges have gone away. I'll go through them. So starting 12 years ago, one of the things that was missing was any sort of content out on the internet on IP6 in any sort of level. Now, this isn't really a problem or a challenge for deploying IP6, but it is a challenge for convincing any bean counters that they need to deploy IP6. Fortunately, we're a small enough ISP. I'm the one who makes the decisions, and I decided to do IP6. But these days, we do have masses of content, as we've just seen from some very interesting slides about how much there is out there. When you look at things like Facebook and Google, you realize that the vast majority of your domestic customers, and they are, of course, the vast majority of customers for a lot of ISPs, that's what they do. So they will be accessing IP6-enabled services and websites most of the time. So there's a reason to put IP6 in now, which is good. So moving forward from the content, you then have to think, how do we connect to that content? How do we get IP6 connectivity in transit? Now, 12 years ago, we started with a tunnel into BT who were connected to, I think, UK6X, I think. But that was our transit. And obviously, there was very little traffic over it, so it was nice and easy. But we moved forward to having connections into Harpen Electric. And the good news is that now, again, from one of the slides we've seen, that transit providers offer IP6. It's been like this for a few years. We had major players like Level 3 come to us saying, do you want IP6? And we said, yes. And we said, what's your tunnel endpoint? And we laughed at them and said, come back when you've got proper IP6. And they did. And we now have IP6 transit from multiple transit providers as proper, directly connected BGP IP6 just working. You still have a slight issue that the transit providers aren't quite seeing the whole of the internet. So you do need Harpen Electric as well, but that's largely politics between large transit providers and Harpen Electric. But it's not easy to get, it's not difficult to get around. You just go with Harpen Electric as well. So we do have the transit. That was lacking 12 years ago. That problem's gone away. You then have our actual equipment in our network, our core routers. Now, we don't use any CISCO boxes, so it was quite interesting to find out that it was 5 years ago that CISCO routers became cheaper and easier to get IP6. So I'm sure for a lot of ISPs that was a turning point in whether it was sensible for them to move forward with IP6. But in our case, we were able to just make sure our network did IP6. We make all of our own routers. We're an equipment manufacturer as well. So we were able to deploy IP6 with no problem. That's a problem that went away 5 years ago for most ISPs. So you then have to look at how you get the connection from your core network to your customers. Now, like a lot of ISPs, we deal with people like BT for backhaul. And we also deal with other carriers like TalkTalk, who use B or O2 as it was. And backhaul networks are generally protocol agnostic. They transport PPP. So the good news there is it didn't matter. Even BT's network 12 years ago would do IP6 with no problem. Well, technically, not quite no problem. There was a bug in their Cisco routers. No slight to Cisco here. It was BT not updating their software. And it took them literally years to update the routers to get past that bug. Fortunately, because we make our own routers, we were able to bypass the bug within a few days and continue to provide transparent native IP6 to our customers. For most ISPs, the backhaul network is not a problem. It's not entirely true for all ISPs. There are some, like cable companies like Virgin, where to get their backhaul network to support IP6, they need to look at major upgrades to DOCSIS 3, for example. So they have some hurdles still in their backhaul network. But for most ISPs that are using a traditional sort of broadband LTTP backhaul, there's no issue with that. You can get ISP all the way to your customer. What do you do then? Well, you need routers on the end of the line. And this has been one of our biggest challenges, and thankfully has also gone away a few years ago. The box you put on the end of your broadband line ideally needs to support IP6. And there were some expensive routers, some expensive Cisco routers. But not just Cisco. Billion came out with a router that supported IP6, but was expensive. This wasn't meant to be a Cisco bashing presentation, honest. Cisco were there, well before other people, which is good, but Cisco routers are expensive. What we needed was cheap tap really, cheap consumer routers, the sort of thing we can give away free with our broadband. Obviously, our customers can buy nicer, shinier routers, and some of them did, but we needed cheap routers that we can give away with our broadband that just support IP6. And some of the router manufacturers are being very strange. They've launched new products that supported IP6, but only in their high-end version of their routers that were expensive. The low-end ones wouldn't have IP6, and they couldn't really explain the logic behind this. So, thankfully, I think the first that came along that actually worked was Technicolor, which is what we're using now. And they had the sense to send some people to our offices, sit down with their prototype routers, plugged into our network, and we spent a day looking at packet dumps and lots of hexadecimal. It looked like we were both in the matrix. And we worked out exactly what they needed to do, and we made some changes on our equipment to make it work really smoothly with their kit. And the end result is we have cheap consumer routers that just work with our customers. Now, that was quite a few years ago. So we then started shipping those to customers, and every customer from then gets IP6 by default. Until then, you asked for IP6, and we were doing it via tunnels. But now it's in the routers. So if you're some granny in Scotland orders broadband from us, we send a router, we plug it in, their iPad will be accessing Facebook over IP6 without knowing it. So pretty much all of the hurdles, certainly from a technical point of view, have been solved years ago. As an ISP, there's no reason not to just do IP6 now. There are more consumer routers. Of course, if you go into the home, beyond the router, you then need to think what in the home uses IP6. Again, 12 years ago, not everything did IP6, but now everything does. Windows, Mac, Linux, iPads, iPhones, Android phones, they all just do IP6 with no problem. So in the home, you've got IP6 working. And there's been quite a lot of improvement in the way these devices work and the way they handle the fact that they have two protocols, how quickly and how easily they switch between them if necessary. So we have the idea of happy eyeballs, the idea that if something isn't right with one of your protocols, your browser doesn't stall for ages. And those are areas that have been improved greatly. And that's partly why the likes of Google and Facebook just enabled IP6, because they know their end users won't see a problem. If they're connecting over an IP4 network, it will just work and it will be seamless. And if they've got IP6, it will just work. So these hurdles have gone away. There's no real excuse. So what's left? Well, the only thing that's left really is the cost of change. These organizations have back-end systems. They have systems for managing the IP address assignments to their customers, for recording those so that they can go back to them later, whether for their own diagnostics or enforcement for any other reason, for technical support staff to understand issues. And you have a situation where if they just turn on IP6 and someone's having trouble sending an email, the tech support staff helping them might need to actually understand what an IP6 address is, because the customer might have no idea about IP6, but is using it, and that's the whole idea. So there is some training, there is some work to do, but there's not really a good excuse as to why they didn't start that 10 years ago, to be honest. Certainly 5 years ago. I'd say almost all of the problems I've mentioned here are probably well out of the way and addressed 3 years ago. By now, ISPs should have had a good plan in place for how they're going to deploy IPv6. They probably have gone through the life cycle of a new version of router. You have people like BT with their own routers, like home hubs. Well, I'd be surprised if the current home hubs don't support IPv6 if they turn it on. It would be crazy if they don't. Although BT famously said they don't support IPv6 to us when we found this bug, and then very quickly changed their tune on that. So it's possible the large players are there. Trying to get a straight answer out of large players like BT is difficult. They probably do have plans behind the scenes. And we may suddenly find they just turn on IPv6 and all of their customers have it one day, which would be a nice big blip in stats when we're looking at who's got IPv6 in the country. Other big players will no doubt do the same. As I say, Virgin do have some technical challenges to overcome, but once they've done that, they may well be able to do the same. Some of the smaller ISPs, PlusNet, for example, they're trialing IPv6, which is good. Zen, on the other hand, are dragging their heels, saying things like there's no demand for it. And we did ask how much demand they had for IP4, and are they going to turn that off because there's no demand? So there are people definitely dragging their heels here, which is odd. We have had people say, well, when there's IPv6 only websites, this is one I would like to ask the panel in a moment. Both of you have looked at stats and you've looked at IPv6 enabled services. Have you looked at how many IPv6 only enabled services there are, and is that an interesting stat to investigate? Well, I'll finish talking, then we'll come back to that. But the reason it came up is people are saying, well, when there's only IPv6 only websites, then we'll look at it. And of course, my answer to that is, well, here, go to www.loops.zen.uk. It's a nice fun game. I didn't invent the game, but we came with it. My son and I were on holiday, decided to watch it just for fun. It's really a fun game, but it only works over IPv6. Why not? It's just a game. But there's an IPv6 only website in the UK, hosted in the UK, and you can't get to it on IP4. So everyone who says when there's IPv6 only websites, we can answer them. Of course, they then say, oh, that's only one website, it's not important. Okay, so how many websites do there have to be? It's a different question you're asking. It's no longer when there's one. And the real answer, of course, is when there are websites that their customers want to get to that only do IPv6. There probably aren't going to be many for a long time. I have a feeling in some countries where IP4s really are scarce and the local population do have IPv6, it's likely that primarily local sites and local services might start doing IPv6 only. You might find if you're dealing with a company in China or something and you can't talk IPv6, you can't send them emails. Perhaps one day, maybe not quite yet. But that's where I suspect it'll go. And then ISPs really will be dragging their heels. I put a point to Ed Vasey earlier about whether ISPs should be required to do IPv6. And one of the challenges is what could governments do? We can't really have a law saying thou shalt do IPv6. That's really not going to work, and we don't really want more regulation. One idea I did have is what if they spoke to trading standards, advertising standards, and said, thou shalt not claim to be selling an internet service if you don't have IPv6, and force the likes of BT and Virgin and so on to redefine their service and their adverts and not call it an internet service anymore because they don't sell the internet. That wouldn't be you must do IPv6, but it would be suddenly a commercial incentive for these large ISPs to maybe think about actually doing IPv6. But I think that's everything.
Thank you very much, Adrian. And I have Alain who wanted to answer one of your questions.
Actually, I have a lot to say on a lot of things, but let me start with the comment on IPv6 on the website, and IPv6 only content. To be very honest with you, if you measure, and we did, how many websites are IPv6 only reachable on the internet today, you're going to end up with a very, 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 very small number. And the main reason is not that there are people running IPv6 only websites or not, but the main reason is that nobody wants to disenfranchise the vast majority of the users. The vast majority of the users on the internet don't have IPv6 today. Actually, it's 100% minus 4%, so that's 96% don't have IPv6. Right? So you don't want to disenfranchise the vast majority of the market. But what is happening is that we have very large content providers, very large ones, that are deploying. We have very large content providers deploying IPv6 only infrastructure. The application is running on IPv6 only. And what they do is they translate at the edge to serve IPv4 users. So basically, the question is not how much content is IPv6 only. The question is how much content is better reachable over IPv6 versus v4 translated back to v6 in the backend. As an end user, you rather have an end-to-end connection with no translation mechanism in between rather than a connection that is translated many times, because every point of translation is potentially something that is going to impact the end user experience, is going to weaken the security, is going to, have a lot of negative impact on your end user experience, right? So as an ISP, I think if you want to guarantee a good end user experience for your users to go to Facebook, you better enable IPv6 because Facebook is actually running IPv6 only data centers. 100% of their backend, 100% of their content is actually on v6 only. And they do the translation at the edge of the data center. So as an ISP, I think that's the question that you should ask yourself. Now, unfortunately, this is not necessarily very visible on the internet. You're going to have to go one by one and understand what they are doing. Because if you want to run statistics and do crawling, you're not going to see that, right? You're going to see a fake IPv4 address answering your request. So that was my first comment on v6 only content. The second comment is actually along the same lines. The main problem and the reason why v6 is not being deployed widely is because the number one, I mean, there was a little bit of a chicken and eggs issue. So why an ISP would put their users on IPv6 and there is no content on IPv6, right? Since June of 2012, that chicken and eggs question is gone because Facebook and Yahoo and Google and Wikipedia and the big ones have enabled IPv6. Therefore, roughly 50% of the content of what people do, right, on YouTube or Google is accessible over IPv6. So the ISP should not have that as an excuse anymore. There is content available out there. It may not be 100% of the content, but there's at least half of it, which is largely good enough. Now, if ISPs don't grow their user base and already provide a globally routable address to every single user with IPv4, why should they bother? They should not. The only reason for enabling v6 is if they grow past the number of IPv4 addresses that they have available. If they're starting to run out of IPv4 address, then they're going to have to, the only one thing that they can do is share the public IPv4 address that they have. And if they start sharing those IPv4 addresses with mechanisms such as carrier-grade NATs, they are going to impact the end user experience of their end users. So the main reason why Google and Facebook and all those people have enabled IPv6 is because they don't want their client experiences to be impacted by an ISP downstream which they have no control and no SLA with to translate and share public IPv4 address. So they prefer to go v6 and bypass all those sharing mechanisms. For the ISP now, why would they move to v6? Well, to provide a better experience to their end users, but more importantly, to avoid the cost of CGN, because the CGN has a cost, and it's an ever-increasing cost. It's not something that is diminishing over time. If you continue to deploy CGNs because you add more users and more devices and more complex applications, the cost of the CGN is going through the roof, and we have numbers and we can model that cost. If you want to avoid that cost, the only option is to deploy v6 and offload a significant proportion of your user sessions from the CGN. That's where the business case is, and we need to break that chicken and eggs issue. That's exactly the reason. Now, ISPs that have decided to deploy v6 have figured that out. They really figured that out. They know how much it costs to deploy CGNs and to operate CGNs and to continue to grow CGNs, and they don't want to incur those costs, therefore they move to v6. That's the bottom line.
Thank you, Alain. Are you saying we're reaching kind of a watershed line in a way, in seeing which strategic direction will ISPs take? Those that will go on CGN full blast and those that will go on v6? Adrian?
Yeah, I tried to cover some of the reasons, the hurdles, but you're right. We are now turning from hurdles, which have also gone away, to opportunities and reasons to take IPv6. And you asked about CGN. A lot of ISPs, especially big ISPs, will have to deploy CGN of some sort, simply because they're running out of IP4. Now, we're Andrews and Arnold, we're in a quite a fortunate position. We've applied for IP addresses quite correctly for our customers, and the difference is a lot of our customers have blocks of IPs. they weren't NAT. They're deployed with real IP addresses. Now, this means we've got about 10 times more IPs than we have customers. So we can now start telling customers, sorry, you can't keep having IP4s, but here, you've got big block IP6, you've got a fixed real IP4, we're not having to do CDN for you, but we're going to have to take away your block. And that allows us to grow massively. But most consumer ISPs have only been giving their customers a single IP4 anyway. So they're now getting to the stage where they run out of IP4s, they have to do CTNAT. And your point there is, it's a commercial thing, CTNAT's expensive. The expense is largely down to the scale of the operation. How much of that traffic is going through that CDN? And that's partly down to the problems customers will face, how many ports are used and so on. Get a lot of that traffic off, get it onto IP6, and you save money. So there's an opportunity.
Another point along those lines, and maybe some lessons learned in other countries that could be applicable to the UK, or, I mean, and other countries, not only the UK. In Belgium, they've done something really clever. Instead of mandating V6 deployments, they've actually signed an MOU between all the ISPs, the police, the Department of Justice, and the regulator. They basically decided that it was okay to deploy CGNs because, as you said, I mean, it's needed. Some people are running out of address. They're not gonna shut down their operation and just call it bye-bye. They need to continue to operate. So it's okay to deploy CGN, but within certain rules. And they've actually signed an MOU, and everybody's applying the same provisioning rules. No more than 16 users for one public IPv4 address, which basically fix the number of ports per users, which simplify greatly the logging that you need to have, and simplify greatly the cyber investigation. If you want to know who was using this IP address, you have to look at 1 to 16 ratio as opposed to 1 to thousands, right? The level of uncertainty is actually much lower, and it's a lot easier to track down and log. So they decided to do that. The side effect of that was that it put an end date to the CGN. Because you know how many public IP addresses you have in your pool. If you apply a by 60 ratio, you know exactly when that CGN is going to be, that CGN path is going to end. And this has had an immense effect on Belgium ISPs deploying IPv6. They all have IPv6 enabled, all of them, and 20% of the country is now on V6, right? And in a matter of 18 months. So it's not impossible. And it wasn't a mandate. It was a common agreement that it was the right thing to do for the overall sanity, let's say, and health of the internet in Belgium in this particular case, right? So things can be done. It's not necessarily a mandate, but it could be, you can use the right business incentive to make it happen. Belgium is a good example of that.
Yeah, thank you. And I guess we are running out of time. We'll do last 5 minutes. Tim, you wanted to add a few things?
Yeah, so on the original agenda, I think you were asking me to talk a little bit about IPv6 standards. So I think the very short version of that is that the original V6 standard, known as RFC 2460, was published in December 1998, somewhere around there. So it's been nearly 16 years since the core spec was put out. And that core spec has been updated a couple of times, but it's not been obsoleted, so it's still there and relevant. And I think, although there's constantly improvements being made to IPv6, just as there have been before, the protocol itself, the core parts of it have been stable for a number of years, and that's why Adrian's been able to deploy it 12 years ago, because it is stable enough for people to implement it and to deploy it. So I think there's a very positive message there. The other thing I just wanted to say is that there is a new group that's been formed under the encouragement of the IPv6 Forum to replicate what's been happening in Belgium and a couple of other countries with their IPv6 councils in terms of bringing together the right type of organizations to share their experiences and to discuss the opportunities rather than the hurdles. So myself and Veronica McKillop of CISCO are co-chairing this UK IPv6 Council. People we have involved are new ISPs, BSkyB, BT and Virgin so far, enterprises, GlaxoSmithKline, Goldman Sachs. These are people that want to deploy and want to share information on how to do so. From academia, there's ourselves and Janet, CISCO, a vendor on board. We're also looking at industry bodies, so with the IE2 involved as well. So the idea there is to try and replicate what's been successful in Belgium and similar countries, Switzerland, for example, just try and get people together to share their experiences and discuss what they can do rather than reasons they can't do it. So if you're interested in that, there'll be a website launching soon, which will be www.ipv6.org.uk, which will have some information on it.
Thanks, Tim. One comment that I want to make is, I think I can't remember exactly who said that, but one of the hurdles in enabling V6, and this is something that at CISCO, but the rest of the industry have done the same, is people are not upgrading simply because they want to support V6. No, very few. I mean, there might be a few service providers that have to do that because they understand the reason strategically, but most of the time, they upgrade for other reasons, because of obsolescence of the platforms, because of new standards from a bandwidth standpoint, because of new standards. So basically, we piggyback V6 into DOCSIS 3.0, into 3GPP Release 9, into Broadband Forum, whatever. And so as you upgrade, so you are taking the example of the cable operators, they have to upgrade to DOCSIS 3.0, not because of V6, but because of bandwidth. Right? They want to provide higher bandwidth to their users. The equipments have to be upgraded to DOCSIS 3.0, which enable 100 meg downstream on cable infrastructure. As a consequence of that, V6 is enabling those equipments. And so now it's just a matter of turning on the feature. The hardware supports it. The same is true for mobile, right? If you move from Release 8 to Release 9, as of a sudden you get dual stack support on PDP context by default, both on the phones as well as on the packet core. So now it's just a matter of deciding to enable V6. It's supported in equipment. So I think and the same is true in a number of enterprise products as well. I think people are upgrading equipment for a variety of reasons. We piggyback V6 into those equipments. So as part of the life cycle, you can enable it. It's just a matter of making the strategic decisions to do it.
Thank you very much, Alain. I did hear one thing that personnel, network engineers and so on, don't know about V6. It's just like they need hours and hours of training to get brought up to date from V4 to V6. Is that a reality, or is this just another one of these things to make people scared about it?
That's a tricky one, because in our case, of course, our staff, yes, some of the staff have been there longer than we've had IP6, but most of the staff have joined the company when we had IP6 already. So all of their training involved IP6. But the issue is not so much, the tech support staff at an ISP aren't network engineers typically. The frontline certainly aren't. And if anything, it's more recognizing the new types of symptoms that are going to come along. We had an interesting case that slightly fooled us recently, where a customer had some slightly odd issues all day. They could get to everything. They could get to email, they could get to Google, get to Facebook, and all this. And we were trying to figure out what was common about things they couldn't get to. They couldn't get to their bank, for example. Took a little while to realise that there was actually a fault where they didn't have any IP4. They just didn't know they didn't have any IP4. Most of what they were trying to do just worked. So new types of faults and diagnosis come along. So it's more a question of training on things like that, as well as the fact that if you get to sort of further into the support, where you might actually be looking at pings and trace routes and DNS lookups, you've got to take into account the IP6 aspects of those. It's not a big training job, but it is something when you're the size of BT and you've got loads of support staff in a call centre in India that might need to ask these questions, it is a little bit more work.
Not zero, right? It's not zero, but it's not insurmountable. But the two things that I would say on this is, yes, this is an issue. It's not necessarily about retraining people. It's about updating their knowledge, which you would do for a number of other things, right? You give them updates on how to use a new version of PowerPoint as well, or Windows, or whatever that may be that they use. That was a bad example, okay? Because you can still use the old one. It does the same thing, basically. But my point is this. So as part of the certification programs, for example, that we have at CISCO, but the rest of the industry is the same, we've included V6. So now if you want to recertify for CCIE or CCNA or CCDP, you better learn V6, otherwise you're going to fail your test, right? Simple. But one thing that I would say is I'm involved with a lot of universities, and I think the education community has to do a better job at putting V6 by default on computer science and networking programs. There are still a lot of students. I know, Tim, it's a teaser for you. but there are still a lot of places where students, and I have a lot of interns in my own organization, that come out of school with a master's degree and can barely decode an IPv6 address, unfortunately. Still the case.
Yeah, I think that's an excellent point. I was speaking to Rob Evans of Janet, who's done fantastic work for the last 12 years or so, probably as well, in deploying V6 on Janet. Yeah, and he said that there's about 150 to 200 universities that have been given a V6 prefix to do something with. They've obviously shown enough interest to request one. They're not given it by default. But only about 10 to 12 of those have done something significant with it, which is really disappointing. And to me, a university is a place where innovation should happen, where environment should be created for the engineers and the graduates of the future to learn about these things that they're going to experience when they move into the real world. So for us, we've done V6. It's on our department's network, most of our university network, well, certainly the wireless network is there, and everything just works. There's no magic to it. And that is CISCO equipment, which is generally very good. Just to counter some of the other points you've heard, I will go on record here as saying we're very happy with CISCO as our supplier. But yeah, I think that's a very important point that universities could be doing more. They're too concerned now with business cases and risk aversion and change control, and a lot of that stuff is needed in a commercial environment, which universities are now. But there's just not enough forward-lookingness. Yeah. I'll tell you a funny story about that just for 30 seconds quickly. It's in my curriculum when I teach it, and I don't often get questions related from invigilators in the exams, but there was an electronics course where I do some V6 on it, and there was a question from the exam room from the invigilator that said, one of the students has said, you promised there would be no IPv6 in the exam. And everyone I know who I'm speaking to knows darn well that I would never have said that to a student. So it's almost certain there will be V6 in the exam. So that was quite a funny story, I think. But no, it is very, very important that the people that are graduating graduate both with the knowledge of V6 from an appropriate amount, not a crazy amount of it in the modules, but also that the labs, the wireless network, and everything that they experience while at the university has it there. And it may be that they're completely unaware of it, like a home user might be. But for those who are doing computer science degrees and so on, that's really important for them. And we have a number of students that have written interesting peer-to-peer applications that assume V6, secure communication applications that don't have to worry about NAT reversal and so on. And they've benefited from that. We have people doing, for those of you with your buzzword bingo cards, Internet of Things, you can tick that one off now. We have people doing sensor networks and embedded devices and so on, and they're using V6. We even built we contributed towards raising £300,000 for Marwell Zoo by buying a rhino, a life-size plastic rhino from Marwell, and pimping it with a load of Raspberry Pis inside it. And that included all those Pis and the whole rhino being V6 accessible and controllable from outside. And that was a fantastic thing. It could wiggle its ears, it could make noises, it could understand what things you were holding in front of its eyes, you could tweet it and change its mood and so on. And with loads of school children got involved with that and got really interested by that. That's a really good engagement thing. But that's, to me, what universities should do a larger part be about. Anyway, I've ranted enough now, so I'll pass the microphone back.
Thank you. I'm glad we have a V6-enabled rhino that can wiggle its ears. It's really comforting now. Last question, and the last two questions, and then we have to break for lunch.
Okay, so I was going to ask about the Internet of Things and the extent to which will what we've just heard about slow down adoption, or the extent to which it becomes ubiquitous, or will it actually force the issue? And I guess the final point was, should I feel optimistic or pessimistic walking out of here? I'm sort of just interested in hearing all those different views.
I can take so the Internet of Things is many things to many different people, right? So it's very difficult to give a generic answer. But I can tell you that in certain industries, V6 is by default because there is no V4. A lot of those objects won't be able to have the logic to select what kind of stack they should be using. They're going to have one stack and they're going to stick on it, right? And most of the time they're going to be quote unquote, statically configured to talk to the whoever they talk to, maybe an anycast address. So in certain industries, this is V6 only. You take all the smart grid industry, for example, the smart meters are working on V6, period. They don't work on V4. There is no V4 stack in the device. So any smart grid infrastructure that we deploy right now are V6 only infrastructure, right? There are other cases in the oil and gas industry, in the transportation industry, where the objects are actually connected, the sensors and the operators are actually connected over V6 only. Now there are a bunch of others IoT that are not using V6 because they don't want to disenfranchise all the objects that you find in the home space. Nobody will come up with an IPv6 only sensor that will control your AC because, again, 94% of the users in the world are still on V4. So we're going to have to manage that transition. Now, should you be optimistic or pessimistic? I'm an optimistic. I see the curves. I mean, it's growing. It's not growing everywhere, but it's growing in big pockets, and there are more and more of those big pockets. UK is not one of those at this point in time, but I'm hopeful. I mean, I'm hearing positive noise from a couple of ISPs, mobile and cable operators in the UK, that this may be coming in a large scale. So we'll see.
Yeah, I'm fairly optimistic about things. In terms of you talk about Internet of Things in home space. Internet of Things always struck me as slightly odd because IP's always been about directly routing packets to an endpoint, and that should just work anyway. And our customers have had fixed IP4 for decades, so it always seems odd that people see this as a new opportunity. But there is a slight snag. People are so used to IP4 with NAT and NAT being considered a firewall and not separating the issue of firewalls and NAT, that all your IP6 consumer equipment is firewalling all the incoming IP6. So it's all very well having your fridge talk IP6, but no one's going to be able to talk to it, even if you want to let them, unless you can configure your consumer-grade router that you might not even have a login to let that traffic in. So it's going to be interesting to see how that develops. I imagine it will be UPnP-type horrible stuff to open firewalls from the inside. But
the Consumer Electronic Forum last year, when they meet in Vegas every January, right? That's where they have a Consumer Electronic show. At CES, they actually made a statement that V6 was going to be the architectural protocol that they're going to standardize on. And that statement was made last February. Now they're working at turning that into specs and stuff like that. So I think you're going to see consumer electronic devices coming out with V6 with a particular set of functionalities that you need for configuration and so on and so on. Yeah, sure. No, sure they do, but at least you're going to have more standardized way of deploying V6 into the consumer electronic devices, which I think is the right way of.
Just one point. One of the little things that's being discussed in the ITF are the sort of filtering policies that ISPs might apply to a typical home gateway. One of the arguments for V6 is open end-to-end. Some ISPs are deploying with their routers shipping by default, allowing end-to-end connectivity, and obviously there's a risk there, and it's early days, and people are obviously going to get the experience of what works and what doesn't. But there are different models that we proposed in the ITF. I think Eric Fink, who I was speaking to, said that some of the Belgian ISPs have that fairly open policy at the moment. I don't know what the Andrews and Arnold policy on that is, but it'll be interesting to see how that shapes out.
Thank you. Last question from the gentleman in the back. Please introduce yourself.
Mwendwa Kivuva from Internet Society, Kenya, Nairobi. We have seen that over-reliance of NAT address translation has made the uptake of has made like in Africa we cannot exhaust our IPv4 blocks because of over-reliance of NATing. Now, when we start using now new innovations like CGN or large-scale netting, isn't it also still we are introducing a new problem into the adoption of IPv6? Because if people see that there is a workaround on implementing IPv6, they will not actually go for the IPv6 because they can do CGN. Isn't it that part of the problem of the uptake of IPv6?
So I think we talked about that a little bit. I think, yes, there is a workaround. That workaround is not something that will work forever because If you do, that means that you're going to be sharing your IPv4, public IPv4 addresses, which are fixed in numbers. I mean, then we don't have any more, with a growing number of end users. And so the higher ratio you have, the higher the cost will be, and the lower the worse the user experience will be. So I think it's a myth that you think that because you have NATs or you can sustain multiple layer of NATs, you're going to be carrying on with IPv4 forever. That's just not true. The second point is that these NAT devices, the carrier grade NATs, have a cost, and it doesn't have a cost only per user or per bandwidth. It has a cost per number of sessions that traverses the NAT. The number of sessions is not under your control. It's under the control of the application providers. When Yahoo opens 140 sessions just to display the home page, it's 140 sessions that goes away in the NAT. When someone starts BitTorrent, it's 700 sessions that goes away, right? Those numbers are not under the control of the ISP. They're under control of the application providers. And they don't care about the number of sessions that they open, because for them it's free. The more sessions they open, the richer the experience is, right? So that's the other point about CGNs. Actually, we have a set of papers that explain all of that in details and how it works and what the cost modeling is. But trust me, try to deploy CGNs because you have to try to bypass it as much as possible. Otherwise, the cost is going to go through the roof and the experience of the user is going to go down. V4 internet quality is going south.
Well, that's a strong statement. Strong-ish. Over to Adrian, and then we'll have, I think, well, let's do it. Our closing words, otherwise we won't have lunch. So whether it's V4 or V6, we won't have lunch. So.
Yeah, I'm not sure what to say. As I said, I'm very optimistic about V6. It really is just working. There's no excuse and there's no opportunities for ISPs. They really ought to be moving towards it. And it's obviously the future. And it's nice to keep the end-to-end model that the internet works on. There's so many other ways it could have been written, but this has proved a successful model in the design, and it's really nice that we can move forward keeping that model without breaking it.
Thank you, Adrian. And next we have Tim.
I'll just sort of reiterate the words I've said before. From our university's point of view, IPv6 is a very important thing for the future. We're very happy that we're running it within our university. Our students are exposed to it. They're using it in their studies. We have researchers that are doing quite large projects. For example, there's people as I speak, I think, in Scotland deploying wireless sensor networks that are just using IPv6. And to us, that's the future of how things are going to be. And we're very happy that we've been involved from an early point, and we're hopefully contributing to other people moving forward with it.
I spoke enough, but I just want to make one closing statement, right? Often the mistake is people think that there is a cost in deploying IPv6. They completely underestimate the cost of staying with IPv4, the increasing cost of staying with IPv4, and prolonging the life, putting V4 on life support. So there is a cost of CGN. There is a cost of a lot of those mechanisms to prolong the life of IPv4. Do not underestimate it.
Okay, well, thanks everybody, and this session is now adjourned. And we'll have all of this recorded, and it will be available on the website, including the slides.